Let's quickly have a look at this, at these two sums. Now, I want to say this, and I'm very honest when I say this, that a lot of you guys, unfortunately, lose a lot of silly marks by the way you write things out. I'm being very honest with you. You lose a lot of marks by your notation. Not that you guys don't know what's going on, but you just throw marks into the proverbial water. So ladies and gents, if I look at a sum like this one specifically, I would always start, again, I would start on one side and try and get to the other side. But please listen to me carefully, grade 12s. You do not just have to work on one side. You are allowed to work left, right, separate from each other, change on both sides and get them equal. You are allowed to change both sides. Don't forget it. So if you have a tan left and a tan right, change both of them. You are allowed to do that. I know most of your teachers don't. They start one side, right, sunshine. They manipulate the living daylights out of that thing. Eventually they get to the end and they go, look how easy. And then you guys go, no, I would never. So I advise you work on both sides if need be. So if I look at this left-hand side, I would change sine 2a into 2 sine a cos a. Why would I do that? Look at where I'm going. I don't want the 2a in my answer. I want just an a, so the only way I can do that is by changing it. Now I'm going to change the tan a as well into sine a over cos a, and then minus 2. So now, that cos and that cos divides away, leaving me with 2 sine squared a minus 2. Okay, say again. I wouldn't. Okay, now ladies and gents. Okay, I'm going to do this sum in 2 ways to show you guys what I did. Number one, I would not factorize at all because look at where I want to go. I want to have only causes in there, right? So I'm going to change my sine squared into 1 minus cos squared. Because I look at where I want to go. I don't just all willy-nilly go and do this. I look at where I want to go, and there's no signs in there. So the first method I'm going to do is I'm going to change this to the sine squared into 1 minus cos squared a minus 2. It's not the only way, but it's for me a nice way. Because 2 minus 2, 0. Leaving me with negative 2 cos squared a, which is my right-hand side. Therefore, left-hand side is equal to right-hand side. But what is the second method if I stop there? The second method, ladies and gents, is why don't I change the right-hand side? I'm going to change the right-hand side, the cos squared a into 1 minus sine squared a. Why would I do that? Because now I'm going to try and get the right-hand side the same as the left. So this gives me negative 2 plus 2 sine squared. But that's exactly that. So therefore left-hand side is equal to right-hand side. I'm doing this method so you guys see I could both manipulate left or right or both, depending on the situation. Okay. Now we get to a lovely question. Question B. Hence or otherwise, determine the values of A for which sine 2A is equal or times by tan A minus 2 is equal to negative 1. So again, what does that expression on the left have to do with that top expression? Why am I thinking that? Because they use the word hence. They use the word hence, and therefore I'm going to try and use what I started at the top with what I have at the bottom. So how does this relate to that top? So, and hopefully you see that I proved the left-hand side equal to negative 2 cos squared A. But now this must be equal to negative 1 because of the identity that I proved. Now this is quite simple, that cos squared A must be 1 over 2 if I divide the negative 2 away. Now quite a few of you, not going to name names, went and did this. Quite a few of you went and did that. And then you called me and you went, "Sir, am I right?" And what was my response? Nope. So hashtag sorry, not sorry. Close but no cigar. What makes it wrong? What makes it wrong? Ladies and gents, do not forget the basic algebra that if I put in my own square root, there's both a positive and a negative answer. So in other words, this is going to change, giving me cos A equal to 1 over root 2, or cos A equal to negative 1 over root 2. And here comes the not so nice part, sir. When you go and write NBT exams, I'm allowed to give you this question without use of a calculator. And now you might go, as I see the shake of the head, might go, Okay, ladies and gents, and here comes the even worse part that I said earlier, remember? In your first year at varsity, no calculator in calculus. That is the not so nice part. But for this, you've got to know that you've got a special angle that is 1 root 2, which is how many degrees? So in other words, A, where is cos positive? In the first and the fourth. So I could have 45 degrees plus k times 360. Or I could have 315 plus k times 360. Or where's A negative? In the second quadrant, so 135 plus k times 360, or A is 225 plus k times 360 degrees. And what did I forget? K is an element of Z. Now, ladies and gents, I want to very emphatically say this. If you got taught by your teacher that whole thing of the rules, if I've got sine of x equal to something, then there's a rule that applies. If there's cos, it's plus minus r cos. And tan has its own rule. Be careful of that rule, because in that rule, there's no real space for without use of a calculator. Because it does not require you to, how do you know negative 1 over root 2? That's where the problem with that formula comes in.